Hi everyone, I'm really happy to participate in this conference, and to be honest, I'm a little bit scared because it's my first public talk, but I will try to do all my best. And today I want to tell you about one of the pain points of Go language, namely nil pointer dereference. And here we go. Okay, Go is pretty safe language, right? Go has garbage collector, so you don't need to worry about memory leaks. Go has escape analysis, so you don't even need to know what the dangling reference is. There are no dangling references in Go. Also, there is a nice concept of zero value, so you don't get undefined values and don't get undefined behavior, and it's cool. All of this makes Go pretty robust and reliable language, except for the one thing. Unfortunately, Go is not nil safe. And I think almost everybody have seen this message before, nil pointer dereference. And it doesn't matter whether you are experienced Go developer or just getting started and new to Go. It's really easy to make mistake while you are working with pointers and end up dereference a nil value. And when that happens, it can crash your entire application, break down your API, background service, whatever. And yeah, actually, a nil dereference isn't something new, and it's not Go specific either, right? The idea of null pointers was introduced back in 1965, almost 60 years ago, by Tony Hoare. And since then, quite a lot of languages like C, C++, Java, etc. Has adopted the same idea and fell into the same trap. And Go is not an exception either. Okay, and all of this has led to countless bugs, validation, and endless debugging. That's why later in 2009, Tony Hoare called it his billion-dollar mistake. He pointed out that IT industry has spent quite a lot of money, billions of dollars, just fixing issues that relates to nil pointers. And yeah, unfortunately, it's not something from the past. It's still happening, even in Go world. Not long time ago, a Go developer shared a story how his company lost $100K, and it's because only for 1 billion for one nil dereference. And yeah, so it's our reality, and it happens nowadays. Okay. Now let me share why I'm interested in this topic. I'm software developer at JetBrains, and I'm working on Golang IDE. And I'm passionate about static analysis tools. I love developing different kind of linters, analyzers, checkers, and stuff like that. And in particular, for the last time, I've been developing a nil dereference analyzer to spot nil dereference issues specifically for Go language. So that's why I'm here, and I want to share my thoughts and experience with you. And today I want to cover the following topics. Firstly, we will refresh our knowledge about nil values in Go. Then I will show you subtle and interesting code examples that relates to nil dereference, and we will investigate them together. And finally, I will show you some tools that can help you to detect and prevent nil issue early. Okay, let's start with the nil basics. As you know, in Go, there are 6 types that can hold a nil value. They are pointers, interfaces, slices, maps, channels, and functions. I'd like to call such types nilable because their value can be nil. Okay, and once we have a nil value, we should be extremely careful with it because almost any operation on nil value will lead to nil pointers and panic and runtime. For example, we should not dereference a nil pointer. We should not access field of a nil pointer called method on nil interface, index nil slice, and so on, so on. So there are quite a lot of operations we shouldn't do on nil because we get a panic at runtime. Also, we shouldn't read or write to a nil channel because it will block our Go routines forever. And yeah, besides this unsafe operation, there are several safe operations. For example, you can add something to a nil slice, take it length, and so on, but it's kind of exception. Let's skip them. Okay, and That's it about nil basics. And now let's move on to the fun part and break some code. And I need help.
I'm coming.
Yeah. Thank you very much.
I thought you were going to be the one breaking the code.
No, that was my talk.
Okay. Do you see code well?
Yep.
Okay, let's start. In this section, I will show you some examples of nil dereferences, and I will investigate them. So let's start with warm-up example. And here we declare a config variable C, and then we set its fields. And as you may guess, if I run this code, it will fail. Let's check it. And yeah, here we get a panic due to nil pointer dereference. So let's figure it out. Actually, if we declare a variable in Go, without initializing it, it's assigned to its zero value. And zero value of all nilable types is nil. So the variable C is default initialized to the nil, and then when we try to set its field, we get a panic. So to fix this issue, we need to initialize it. Let's do it. Yeah, and let's simplify code a bit. Okay, now it looks pretty fine, and we fixed this issue. Let's check whether code works now or not. And no, it doesn't work because we have another issue. Actually, we get a panic due to assignment to entry in nil map. So what happens? We initialize the variable C, but we don't initialize its fields. So that is, the options fields is also default initialized to nil. And when we try to write something to a nil map, we get a panic. So to fix this issue, we need to initialize this field like this, and now everything should work. Yeah. Actually, although it's a toy example, but you can make the same mistake in your real code because it's really easy to add some nilable field to your struct, then forget to initialize it somewhere in your code, and eventually you will get a nil pointer dereference. So instead of initializing struct like this, we can extract it to a constructor. Okay, and let's move on to the next example. Okay, and this example, here is example of the real code. I extracted it from the real project and simplified it a bit. So it's not a toy example, it's a real bug. And yeah, what happens here? First of all, we try to load config from the file, and if it fails, meaning that config is nil, we try to load it from the environment. And if it still fails, meaning that config is nil or error is not nil, we return immediately, okay? And otherwise, if we manage to load it somehow in either way, we just print it to the console. So this code looks pretty fine, but there is a hidden bug here. Actually, let's figure it out. So there are two different config variables. This config variable and this config variable are different. They are not the same. In Go, we can declare a variable with the same name in the inner scope, like this. And then this variable will shadow the variable from the outer scope, this one. And that's why it doesn't matter what we do with config variable here. It doesn't affect the original one, right? So let's imagine that load from file return nil value. So the original config is nil. And the load from environment returns some not nil result without any error. And in this case, we don't return immediately. But the original config is nil, so we get a panic here. Let's check it. And yeah, so we get a panic because of potential nil, because of nil pointer dereference. Okay, and this bug is really dangerous because most of the time your program works correct. So, and only in some cases the nil dereference can happen. So I just want to highlight here that we should be careful with shadowing of variables, and sometimes your IDE can highlight that this config variable and this config variable are different. I don't know whether you Yeah.
We can see.
Yeah, cool. Nice. Let's move on to the next example. And yeah, I really like this example because if you encounter it for the first time, most likely you will spend quite a lot of time investigating it, like me at the first time. So here is quite straightforward code. We just load file, and then we want to validate its content. And if it correct, if content is valid, we just print file is valid. Otherwise, we call a panic. So everything pretty straightforward. And now let's consider the case when validate file returns some nil error, returns nil error. So validation is success, and so we expect the program to print file is valid. Yeah? Let's check it. Oh, something went wrong. Actually, we get a panic with the message error is not nil, file is not valid. And it's really strange because we return nil explicitly. From here, we return nil error. And so this condition should be false, and we shouldn't enter this branch. But for some reason, something went wrong. Okay, and to understand what is going on, let's take a simplified example. Here, we declare our custom error variable of pointer type, and then assign it to nil. And then we assign this variable to error variable of error type, and we want to answer the question whether this error is nil or not. So, as you may guess, if I run this program, this error will be not nil. It's also confusing because we assign it to nil. So, and let's figure it out. Actually, in Go, any conversion from the pointer, from any pointer to an interface value results in a non-nil interface value. It doesn't matter whether the pointer is nil or not. The result is always not nil interface value. It relates to some internals of how interfaces are represented under the hood, but it's out of scope of this talk, so let's keep it. But let's remember this rule. So now we can get back to the original example, and now we can investigate it. So here we have a pointer. So it's a pointer of validation error. And we have an error, and error is something of interface type. So here we have an implicit conversion of pointer to an interface types, and that's why the error variable is not nil here, and we panic. So yes, actually, it's really confusing. And my main point here, so first of all, we should know that any conversion of a pointer to an interface results in a not nil value. And the second point is that we should never use a custom types of error as a result functions, as a result types of the function and method, because it's leads to bugs, obviously. So instead, we should do something like that. And now we fix the issue, and now file is valid. So because we don't have this conversion anymore, right? So let's move to the last example. And in this example, I want to show you that sometimes it's almost impossible to spot the issue because you may not have the full context. So here you can see a pretty straightforward code. We just create a new user, we just create a new user using new user constructor and then print it to the console. So this code is pretty straightforward, and it's definitely correct, but can we get a panic here? So let's check it. Yeah, we can get a panic here due to nil pointer dereference. And it's confusing because this code looks fine, right? And to understand what is going on, we need to dig deeper and take a look at the body of the new user. Okay, now we can see that there is something strange here. In some cases, for some reason, constructor may return nil value, and it's not idiomatic code, right? If we want to return some bad value like nil, we should return the error, not nil error, as well. So let's fix it like this. And let me move this function to the main file just to see the full picture. Okay, and now we need to handle error here. Right, so, cool. Now we have a correct code, right? Because so we improved our code. We return result together with error. We handle all errors properly and propagate them properly, and we handle errors properly here as well. So this code looks fine. It looks like idiomatic Go code, and it's definitely correct. So, but I have the same question. Can we get a panic here? Actually, let's try. Nobody knows, right? Yes, we can get a panic here, even in this code that is correct. Believe me, this code is correct. And to understand what is going on, we need to dig deeper once again and take a look at the body of create user. And only now we can spot the original issue, the root cause of the issue. It's return nil-nil statement. So here we return a nil result together with nil error, and it makes a nil result valid. So it doesn't matter whether we handle errors properly. The nil-nil pair propagated throughout our program, and nil dereference happens here. So we can fix it, like introduce, like return not nil error, say this one. And now we finally fix the issue. Let's check it. Yeah, cool. So my main point here is that we should not use return nil-nil statement because it's also source of such bugs. And the second statement is sometimes it's quite hard to spot the issue because you may not have the full context, the full code. So you can see only some parts, but the root cause of the issue can be located far away from what you can see. Okay, and actually that's it for the coding part. Let's return back to the presentation, and thank you very much for assistance. Okay. Now I'm hearing myself. Okay, we have considered several interesting and subtle bugs that relates to nil pointer dereference. Now let's take a look at tools that can help us detect and prevent such issues early. So here we go. To detect bugs early and automatically, we can use static analysis tools. And there are at least 3 such tools in Go. They are govet, static check, and golang CI-lint. Each of these tools has checks for different kinds of bugs, and that's why I call such tools general purpose. And in particular, they have checks for nil dereference. For example, govet has a nilness analyzer that can spot some kind of nil dereferences. Okay. However, all of these checks are pretty straightforward. They can spot only simple bugs or common mistakes. For example, they can spot issue in the left. It relates to the default initialization, but they cannot spot the issue in the right. And the right example shows an important limitation of all such analyzers. All such analyzers perform only local analysis. It means that they analyze each function separately in isolation, and so they cannot reason about anything beyond the current analyzing functions. And that's why, for example, they cannot understand that function foo returns nil, and so they cannot spot the nil dereference here. Although this example is really simple, right? Extremely simple, but they cannot spot them. Okay, and this local analysis is not enough for detecting real nil dereference issues, and because in the reality, the nil value creation and its corresponding dereference can be located far away from each other. They can be located in different functions, in different files, or in different packages. And to spot such issues, we need to perform more powerful analysis. So, and the good news here is that we have 2 advanced nil dereference analyzers. They are nil-away and golang nil dereference analyzer. So, nil-away is developed by Uber team, and it's designed to work offline, for example, during build time or in the CI/CD pipelines. Golang analyzer is developed by mostly me and other guys from the Golang team. Woo! Thank you. So feel free to ask me anything about it. I'm really happy to share its internals. And yeah, This Golang analyzer is mostly developed to work on the fly in the IDE, so it can spot issues while you are typing your code, like a regular inspection in the IDE. Okay, and both analyzers perform deep interprocedural analysis. It means that their analysis is not limited to a single function, so they can analyze kind of whole project, and at least they can understand how nil values are propagated throughout your program. Thus, both analyzers can spot more subtle and more interesting issues in your code, and in particular, they can spot almost all issues that I've shown to you previously. Okay, now let's briefly take a look at how it works in action. I need assistance, please, once again. Thank you very much. Sorry for bothering you. Okay, and let's take a look at Golang Analyzer first. I need to enable all inspections in the IDE. Then let's introduce the bug again. And yeah, here we go. So here is the last example I've shown to you previously. And as you remember, the root cause of the issue is located far away from the place where nil, this one, return nil nil, is located far away from the place where Nil Dereference happens. And what?
You're good. You're good. Right there.
Oh, okay. So, and as you can see, Golang Analyzer manages to spot this issue, and moreover, it can show the full path from the nil source, from the root cause of the issue, throughout your program to its corresponding nil dereference. And yeah, now let's take a look at nil-away. So actually, nil-away can do the same. You can run nil-away from the terminal, like this one, and it also can spot this issue, and it also shows the full path from the nil value creation, like this, and its corresponding dereference. So, as you see, both analyzers can track how nil values are propagated throughout your program, and that's why they can spot hidden and more interesting bugs. Okay, and now let's get back to the presentation. Thank you very much. Okay, we have considered several static analysis tools, and I encourage everyone to check them out, all of them, and maybe even use them in daily life, because they can all save your time as well as mental health. And
Money.
and money, of course, yeah, 100K. And that's it about detecting and preventing nil issues. Now let's move to the conclusion. And let's summarize what we learned in this talk. First of all, we found out that nil dereference is still serious and risky problem, even in Go world. Secondly, we saw that it's very easy to run into the nil dereference. We investigated several subtle bugs related to it, so we should be extremely careful with it. And finally, we looked at several static analysis tools that can help us to reduce the number of bugs in our program. So, and I encourage everyone to use them, Golang CI, GoVet, and stuff like that. Okay, and to wrap it up, let's be careful with nil, use tools to catch bugs early, and make our code safer. So that's almost it. I just want to leave some resource for you. If you want to get examples that I've shown to you, you can use this QR code. And also, I won't suggest you to read this book, 100 Go Mistakes and How to Avoid Them. It's really interesting book. There are quite a lot of subtle and interesting cases regarding the Go language, not only about nil dereference, but about everything. It's really interesting and it's worth reading. So that's it. Thank you for attention.
That was awesome. We actually have time for maybe one or two questions if anybody has a question.
Sorry. Yeah, I've been quiet so far. So you did the example of returning the custom error. I wanted to clarify. It's okay to return a custom error struct as long as your return type is an error, right?
So could you repeat, please, which example?
You return in that error.
Uh-huh.
and originally it was a pointer to a.
Yeah, original to pointer, yes.
If you did that, you change the return type to be error.
Yes, to interface type.
Still fine and would not introduce a bug to in the code return a pointer to your custom struct type.
Yeah, I guess.
Is it the conversion that's the problem? Like,
It's the type in the return.
it's the type in the return, but
In the return.
like it's canonical to return custom errors as long as like the return type is not.
Yes.
It's
So
not a-
set
it's not
aside
a-
the interface.
Mhm. Yeah.
Alright, cool.
One more?
Yeah, sure.
Yeah. Is this something that you could put into the compiler? So no team could put into the compiler?
Oh, it's a really interesting question because I have read 3 proposals of introduction annealable types to Go compiler, and they all were rejected. And most likely, the next one will be also rejected. So I don't think so. But I really interested in it because it will be nice. I think it's possible. So and as I know, the main point from the Go team why they don't want to introduce nullable types and make Go nil safe is that, like, the first point is simplicity, the second point is backward compatibility. So yes, and that's it, I guess.
Awesome. Thank you.